In part 1, we looked at how energy is involved in every chemical reaction. We applied Hess's law to quantify the energy in a chemical reaction. In part 2, we looked at combustion reactions and how some fuels produce work. In this video, we'll look at some real-life examples of how we use energy in chemical reactions. Here are the heat equations we learned about earlier. Stop the video and review these equations. In an earlier video, we looked at how a heat engine works. A fuel should produce heat and produce work. A heat engine produces work when a gas expands and pushes against the piston. Let's compare two fuels, octane and hydrogen. Many people believe hydrogen is the fuel of the 21st century. Which fuel is better for a car engine? Stop the video and answer these questions. And the answers are, octane produces work, but hydrogen does not. So octane is used in car engines because it produces heat and work. Hydrogen produces heat but not work, so hydrogen is better suited for a fuel cell to make electricity. We consume a lot of fossil fuels. Note that in 2007, the US, our country, used almost a quarter of all the oil. Of all the fuel we use, friction consumes about 10% of a car or truck's fuel. Some of you may study tribology, which could result in a significant saving in fuel consumption. Of the price we pay at the pump, most of it goes to the crude oil suppliers. Many of you are concerned about the environment and climate change. So stop the video and do this calculation. And the answer is, so note that 1 gallon of gas, which is about 2.7 kilograms, produces over 8 kilograms of CO2. A few years ago, I drove this car, so stop the video and see if my car passed the smog check. And the answer is, what a relief. Us humans emit 24 billion metric tons of CO2 each year. So here's a few things we can do with CO2. Here are a few companies which are using waste CO2 to make chemicals. We use glucose for energy. Stop the video and answer this question. And the answer is, and let's convert from kilojoules per gram to food calories per gram. This number makes sense because on a food label, 1 gram of a carbohydrate such as glucose is 4 calories. We grow a lot of corn in this country. Here's how it's used. Ethanol is used as a fuel, so stop the video and answer these questions. And the answers are, for part B, use delta H reaction. Cellulose can also be used to make ethanol biofuel. We still have a lot of recoverable oil and gas on our coastlines. Hydraulic fracturing or fracking has enabled this country to meet our domestic energy demand by extracting natural gas from shale rock. However, fracking uses quite a few chemicals, but the methane extracted from fracking may make climate change worse. Our energy utility companies use therms and kilowatt hours for their energy units. Based on their energy rates, is electricity cheaper than natural gas? Stop the video and find out. And the answer is, you're getting good at conversions. Methane is the fuel in natural gas, so stop the video, apply these strategies, and answer those questions. And the answers are, what fuel source is used to generate electricity? In 2009, most of it came from coal. Due to fracking, our country has extracted a lot of natural gas. In 2016, more electricity was generated from natural gas than coal. We compared natural gas to coal. Stop the video and confirm or refute this statement. And the answer is, natural gas emits about half the amount of CO2 than coal for the same amount of energy produced. We use a lot of energy. Most of this energy is produced by burning fossil fuels. But check this out. So maybe you will figure out a way to cheaply convert sunlight to electricity. In 2008, only a tiny amount of electricity was generated from the sun. The efficiency of these solar devices is pretty poor. Maybe you can figure out a way to improve the efficiency and lower the costs. This is how you use energy at home. Stop the video and figure out what uses the most energy. And the answer is to heat your home. This picture shows our U.S. energy use in 2013. Stop the video and figure out the fuel source which generated the most electricity. And what is the main use of petroleum? And the answers are, now we got to keep our clothes clean, but what uses the least amount of energy, our washer or dryer? Stop the video and figure it out. And the answer is the washer. Now if you want to use the dryer less and use less electricity, use solar energy. We looked at how a heat engine works earlier. How does the refrigerator work? Stop the video and answer these questions. And the answers are, and for the last question, we have to supply work to compress a low pressure gas to a high pressure gas. In step B, a gas condenses to a liquid. This phase change is exothermic, so heat is released. In step C, the high pressure refrigerant liquid passes through a valve to become a low pressure liquid. And in step T, the liquid evaporates to a gas. This phase change is endothermic. When the liquid gains heat, what loses heat? Stop the video and answer that question and these questions. And the answers are, the refrigerant should have a low boiling point to cool the air inside the fridge. And the refrigerant should be compressible because, in an earlier video, we compared a rock and gold cup in a parking lot on a hot day. Those two objects or substances contain internal energy. Substances do not contain heat or work. Under certain conditions, internal energy can be converted into either heat or work or both. We can directly measure heat and work and relate those quantities to internal energy and other thermodynamic quantities. Ugh, you got a flat tire. As you pump air into the tire, you feel the valve stem get warm. Stop the video and answer this question. Here's how you get the answer. Internal energy is the energy inside atoms and molecules due to the kinetic and potential energy of the subatomic particles. So if delta E increases, the kinetic energy increases and the temperature will increase. You want to go skiing but there's no snow, so you make your own snow. So a snowmaking machine has air and water compressed under high pressure. The air and water pass through a tube and expands rapidly into the atmosphere to make snow. Stop the video and answer this question. And the answer is, delta V is greater than 0, that means work is. So if delta E is less than 0, that means the kinetic energy decreases, which means the temperature decreases enough to freeze the water to make snow.